Hi everyone. In this video, we are going to see how to simulate the interfacing of SCADA with PLC when we have no PLC hardware. This is the simple application, that is water level controller, for which we are going to develop the SCADA screen and animate the working of water level controller. This is the simple circuit diagram where we will have two push buttons for turning on the automated system, another for turning off the automated system. We are going to control the on and off of the sump motor, which is used to pump the water to the tank. Right, the same operation what is happening in real world that can be seen on the SCADA screen. Even turning on and off of the system can be controlled using the SCADA screen. Right. We have known that this is the PLC program. That is X0 and X1 push buttons are used for turning on and turning off of the system, whereas this M0 and M1 are the push buttons which are used from the SCADA screen. We know that the real world applications can also be controlled, can also be operated using the SCADA screen. These two buttons, that is M0 and M1, are used for turning the system on and off from the SCADA screen. Then X2 and X3 are the sensors that are connected in the tank, whereas X4 is placed in the sump to see whether there is a water in the sump or not. So this is the ladder diagram that we are going to implement using the SCADA screen. Now open DIAView SCADA screen developer. Go to new project. To give any name, we can give a CA simulation for water level controller. This is the name I am going to give. You take empty screen. Now the list of parameters for this particular application have come here. First of all, we need to develop a window. You right click on that and say new window. This is the SCADA screen. And we know that for water level controller, we need two push buttons, one for starting the automated system, another one is for stopping the automated system. For taking the push buttons, you go to gallery, then click on push buttons. Then take this button 2 and drag on the screen. So we need two push buttons. For that, you can even copy and then paste beside that. Yeah. And we need one sump and one tank. From the sump, we are pumping the water to the tank when it is vacant. The sump and tank are available in the valve vessels. For placing the tank, we need one elevator. Just click on that, then drag on the screen. Yeah. Then let me take a tank to place on that. So drag it down in the gallery. Take this tank, then you can animate it. I mean, you can choose the size. You just Let me pull this down. Still. Let me make it bigger. Right. Yeah. Now let me take some. Here itself we have in the name of sink. Yes. To indicate whether the sump motor is running or not, I'll be taking one indicator which I place in the sump. Take this pump, then drag on this. This is the sump motor. Now I need a pipe to connect between the tank and this motor. So to connect pipe between tank and this motor, I'll be making the screen big. Go to extension, sorry, view, then go for full screen. Now you go to toolbox, you take this pipe, start from the tank side, single click it when you want to take it on. Yes. Double click where you want to end. The pipe comes, I will exit from full screen. I can choose the size of the pipe. We click on this and choose 5 feet, let it be 20. Then you place it so that it looks connected. Fine, I guess. Yeah, here also it is done with the fittings. I think it's fine. Now you take one more little pipe to connect another end of the sump motor to the water. Wherever you want to end, you just double click it. Similarly, you can choose for change of size. So for 20, it's mismatching. You select and drag it using arrow marks. Yeah. And we know that there will be 2 sensors placed in the tank. We can place any number of sensors for perfect automation. For simplicity, I am taking 2 sensors. You go to gallery there. Then you go to sensors. You choose any sensor for that matter. You drag it here. Then we can right click, then we can do some rotation operation. This I'll be placing in the tank. So if this is this one more sensor we want, we can just copy it and paste it. The new one will come very closer to that. This is the tank upper level sensor. So these are used for detecting what is the water level in the tank. Now we can have a status of this motor and also the sensors of the tank. Now we can have some indicators from indicating instruments. As we need some sensors, I will click on indicator, one of the indicators available there. Then I can go for copying it. Select that and we can even copy that. Now one more indicator we need for knowing the status of the motor, to know whether it is on or not. You take diode 4 and make it here. For simplicity, we have just taken two sensors from the tank. Here, one more has come. I'll delete it. So this is, I can name it as a tank low level sensor. For naming, again we have to go to toolbox, then go to text. Then let me start with the start button. If you select text and click on this screen that comes there, I can name it. You go to A to Z. Here you type start. Then again you click on the screen. The name comes there. Choose it and you can drag even. Then you copy it. You can copy it and paste it. We can change the name, the property STOP, stop. These are the two push buttons for turning on and off of this automated system. Now we can name these sensors as well. Sensor indicators, of course. This is, we'll have to go there to the property for editing the content. Tank. Tank low level sensor. Click on the screen. The text comes over there. You can drag it and copy it. You can paste it. Then again we can go for text, then click here, then go to properties for changing the text. This is sump motor indicator. We can send this indicator to the next line so that it looks clear. Yeah. Can bring it down. Yeah, this is the control panel we have where we can control turning on and off of the automated system, and also we can see the status of various sensors and also the actuators. Now we can still make it to look beautiful. I just brought one rectangle, then I'm sending it back. Right click and then layer, send to back. So this is the control panel. So I is coming up. We can change that. Each time we have to go there. Enter. This is how it looks. Now let us see how the SCADA screen looks like now. I'll just say run. Just ignore this warning. Yeah, this is how the SCADA screen. The animated things are shown here, and the control panel for controlling the operation are shown here. Now we can animate this. How when the pump has to start, when the pump has to when the automated system has to read the sensor, everything has to be controlled through the PLC. In real-time applications, the SCADA and PLC can be interfaced. Since this is only the simulation, how to do the simulation, I can show that. So we are going to simulate the water level controller. I will be taking one switch for releasing the water from this tank so that it will be more interesting. I'll go to gallery, take one button. I'll take one toggle switch. Whereas whenever I press this toggle switch, the water goes out of this tank. And I'll connect the pipe to this toggle switch. I need pipe, it will be there in the toolbox. Basic graphics, then pipe. The water has to flow from top to bottom, then you have to connect like this. Whenever it has to end, you just double click it. You can increase the size, but it's not necessary now. Now we need to animate the things. To animate, we need to write the program. To write the program, we need the variables to be linked with these IO devices. Now we need to take one variable window. Just right click on variable dictionary. Otherwise, double click on that. Now variable dictionary will open. Now keep on adding whatever the variables we need. We need many variables. One is start. This will have only two values, that is 0 and 1. So I will be selecting digital. Then stop. This will also be holding two values. So I took digital. Then I will be needing one latch. Say latch 1. So this also holds digital value. Then I'll take two sensors, tank low level sensor. Then one for tank high level sensor. So I need to animate the tank. I can show the water level in the tank by animating it. So I'll take one variable for tank. And I want to leave the water whenever I am looking for it to animate it better. So I'll take one tank tap. Tank tap. Since the tank is tank, we have to animate. So I will say it can hold the value. It can hold 1000 liters of water. So it has to show the values between 1 and 1000. I'll have to select it analog. Then the minimum value would be 0 and the maximum value I will say 1000. 1000 liter of water it can hold. These are the list of variables, and one more variable I need for some form. This is also digital. Now, in real world or in the simulation, we need to link these variables to the ports of PLC or memory of PLC. So we need to select for which PLC we are going to write the SCADA script. Now you go to IO device, right click on IO device, you select on new device. Since we have worked on Delta PLC, that is, we have got Delta PLC, I chose Delta PLC, and I am using serial ASCII communication with Modbus. I choose that. Now, if we are really configuring PLC for kind of communication between SCADA and PLC, we need to choose this. Go to COM1, select 7 bits, stop 1 bit, and parity is even. The same thing has to be selected in the PLC side as well. Say OK. Then say OK. Now I will be linking the real-time IO ports and memory of the PLC, Delta PLC, to the variables and the program of SCADA. Now I can check the parameters here as well. So whatever I have given there, I'll give the same thing. It doesn't no need to be same thing. Yeah, here I'll be taking a memory bit 0 for holding the value of start function. and this hardware will be linked with the start variable of my program. Whatever the program I write for start variable, the same function will happen on memory of that particular PLC. In the same way, I'll be adding all the variables. I'll be linking with all the variables and the PLC parameters or PLC IO ports. So as I said, I'll be taking one latch 2, latch 1. It's okay, it can be memory 2. Yes. Now let me see what are the variables I have added. Tank low level sensor, high level sensor, and tank. Yeah, you add one more thing. Tank low level sensor. Now this I have connected to a PLC port 2. That is input port 2. So I'll be choosing this. That is, if it is even it can be used in real time. Whenever a PLC receives the data on X2, this will be reflected in the SCADA screen as well. Since we are simulating, nothing to bother at this particular stage. I just choose the next two. This is tank high level sensor, and this is connected to X3 of my PLC. Yeah. Now add PA tank. Tank is a memory which has to hold the value up to 1000. So I'll be selecting the data register for that purpose. This is the first data register I'm using, so I'm using D0. And whatever the program I have written will be for tank. So this tank variable is linked with the D0 of that PLC. Now we need tank map and sum pump. I can even copy from the variable history. This I can choose it to be a memory because just 1 bit I need, one digital value. Since I have used it still M0 to M2, I will give M3 here. This I will be linking with variable tank tab, and we are interested in sump pump. I mean, which we are controlling through this automation. Paste. Give sump. This is how I link the objects on my SCADA screen with variables, and these variables are linked with the IO ports of my PLC. So now I will show how to link the objects with the variables and then the IO port. Start button. Click on the start button. You go to animation and you choose which variable it has to be linked with. This way, this has to be linked with start. I mean, whatever the program I write for start, it will work with start. Let it be always green or blue. I choose for start, irrespective of whether it is 0 or 1. it shows blue. And some operation has to happen when I press on the start on the SCADA screen. So for that, you should go to event. Now, when I click it, this automation system has to start. So I'll do it with my mouse button, left mouse button. When I press it, you go to event, then click on three dots beside to this left button, object, variable, then start is equal to true. It means what? When I press the mouse button, it will be read as true. Then save. If there are any errors, it will show. No errors, save and exit. When I release the mouse button, it should be read as false. For that, I'll do the same operation. Choose the variable to say is equal to false. Save and exit. That is when I press the mouse button, it will be read as on. I mean true. When I release the mouse button, left mouse button, it will be read as false. Same thing has to be done for stop. When I press it, it should be read as equal to 2. Then save. If there are any errors, it will show. When I release the left mouse button, it will be stop. I mean, it will be false. Save and exit. And now I link these sensors, low-level sensors, with variables. Go to animation, select the tank low-level sensor, go to animation. Under animation, you go to child animation, and you link the variable. We have used tank low-level variable for that. You double click on that and say OK. Say OK. Similarly, this indicator, you link with tank high-level sensor. This you link with the output of our project, that is sum motor. That is whenever sum motor is on, the same status is indicated here. Double click on sum pump. Even the same status can be seen here. I mean, it can be animated here. So you select this pump in the sum. You go for go to child animation. Here also you should link it to sump pump. Say OK. Say OK. Then even you can animate this fan. Means the fan will be rotated when the pump gets on. That is to be linked there. Say OK. for simplicity, we are not animating the water in the sump, but we are going to animate the water in the tank. We know whenever I press this tap, the water has to come, water has to be unfilled from the tank. So for that, I have used this switch. We know that. Select that switch and we go to child animation. Then you select tank tap. Say okay. Okay. Now there should be outflow of water indication when I press this switch. For that, I'll have to link that pipe with this tap. Say okay. Now this sensor, tank low level sensor, again I should link with go to visibility. Yes, we'll see the blink. Here we select tank low level sensor. That is, it blinks according to the water in the tank. Say okay. Then you choose another sensor. That is tank high level sensor. Go to blink. Choose the variable there. Tank high level sensor. Let it blink fast. Now I'll have to animate the water in the tank. That I'll be taking this tank, go to child animation, then choose the variable tank. It means whatever the program I write for variable tank, it will be applicable to this. And say okay. Then I said the maximum value that the tank will have is 1000. It means 1000 liters, which will be equal to 100%. That we have to give here. Expression I should choose. So let us tank. Say okay. Now the linking of each object with the variables and then the PLC thing has been done, and we need to link these pipes as well. It means there will be indication of water flow when the sump pump gets on. That will be again has to be linked with sump pump. Say okay. Again, this pipe has to be linked to the sump pump. Say okay. Since it is not really connected to the PLC, each sensor data from the tank has to be done through the programming only. Now I will say how to do the programming. We'll have to open one script and then conditional script. Now we have to add to which device we are writing the program. That we have to mention. Click on conditional script, then it appears here, then click on add. This line appears there. The under expression, you have to choose for which device you are writing the program. For device 0. that device we can see here. So that is there only we have created all those parameters. Here we have to write the script. Here we need to write the script. So writing the script takes some time. So I'll be pausing this video and then I'll be executing this. Then I'll replay the video. Yeah, I just worked on this script. We know that whenever the start button is pressed, we have to start the automated system. For that, since I've used a push button, I have taken some latch to latch the status of the start button. That's what if variable start is true, then variable latch will be true. And whenever stop button is pressed, allow to remove the latch. For that, for that purpose, I have used these three sentences. And automated system or the motor will be turned on according to the sensors. Only the start button is pressed. In other words, when we have a latch, which is proportional to the start. If the start button is pressed, then I allow to work according to the sensors. And we know that when the water comes down the low level sensor of the tank, we need to turn on the motor. For that purpose, if the water is below both the sensors, it means we need to turn on the motor. For that, I have taken one more latch here, variable dot latch 2. So with this latch, I am going to turn on the motor. And when I am going to stop the motor, when the water in the tank reaches above the tank high level sensor, that is, whenever the water reaches above the high level sensor of the tank, this sensor data will become true. If it is true, I am taking out the latch which is used for turning on the motor. Now I am using this latch to for turning on and off of the motor. That is, if latch 2 is true, it means if the water is above the higher level sensor, sorry, if the water is below the low level sensor and the latch will be true. If the latch 2 will be true, then I am going to turn on the pump. That is, variable sump pump will be true. And if the sump pump is on, the the tank will be filled up. So I am adding 1 liter every time. Every time this instruction is executed. That is, else, if the latch is not true, it means the water is above the high level sensor, then I should keep the sump pump off. Then we have to update the status of the sensors as well, because we have not connected real-time sensors from the PLC, the SCADA. So we need to work on that sensor data according to the tank water. We know that when the tank water is less than 200 liters, say both the sensor data will be false. When the tank is between 200 and 950 liters, we know that the lower sensor will be touching the water and high level sensor will not be touching the water. So in this way, and if the water in the tank is above the 950 liters, then both the sensors will be touching the water. Then a data will be come from the both the sensors. So we are making them force. In real world, this sensor data is readily available from the sensors, but it is just the simulation. We need to update the sensor data according to the tank. So from this data, we are turning on the sump motor or not from these instructions. If the latch 1 is false, it means if the we are taking out the latch 1 from the stop button, we know that when we press the stop button, the latch 1 will be false. That is, when the start button is pressed, which in turn latch 1 will be off state. So in that case, the sump has to be turned on to have a control of the automation system. That is, whenever the start button is pressed, then only these instructions will be working. When stop button is pressed, these two instructions will, or these two statements will work. And to make the animation better, I have used one tap as we have seen in the screen. If the tank is about 200 liter and if the tap is pressed, I mean if the tap is on, the tank water has to be unfilled from the tank. I mean each time this instruction is executed, the water from the tank will be out by 1 liter. So this is the program. We have worked on it. Save and exit. Now, before going to that, I had missed one particular step. I will show you now. So you select this sliding switch for turning on out of top tank. Then you click on here. For this, I will have to link this variable tank tab. Otherwise, linking of the program and this animated screen will not work. So similar in same way, go to variable, then select this tank tab, then say okay, as we did previously. Yes. Now I'm going to run it. I hope it will work so because we have just tested before starting the recording. I have run it. Ignore the error that comes there. Now we can see the status of the sensors of the tank. See, there is no water in the tank. So no sensors touching the water. So no data from this sensor. It is shown by a red light in the indicators place. Even though there is no water, it is not turning on the sump pump because I have not started the automated system. Now I'll press the start button. It will read the sensors. According to the sensor, it will decide whether to turn on the sump pump or not. Now I started based on the sensors. It has started the sump motor. So I have not animated this sump water. I have just animated only uh, the tank water. So to reduce the time required for execution of this SCADA, we can even animate this. We know that see the water has reached above the low level sensor, so it is indicated by the indicator that we have used. See when the water is filled up is above the high level sensor, the same data will be appearing on the tank high level. Sorry, it has to be tank high level sensor HLS. So tank high level sensor data also will come from the sensor. For this, we have written the script. If it is a hardware, we don't need to write a script for this sensor. The data will be directly available there. Now you see, the data from the high level sensor also has come, and the pump has stopped working. And the same indication is shown in this indicator. Now, I'll be releasing the cap here. Now you see the water is below the high level sensor, it is not touching. So that can be seen here. And the water is draining out because I have turned on this tap, the water is going out. So this I am using left button and right button. This I have programmed in the window screen that I can show after the working of this. The water goes below the low level sensor, the motor turns on again. We know that. In fact, Now I'll stop this. So it has to be turned on. Why? Because I have written a script there. The water will not go out. Yeah, I had not opened this tab till it has reached 200 liters. So I'll make around 150 because the motor will be turned on only when the water goes below the 200 liters. There will be some two mismatch there. I'll save and exit. Now we can see that there. Let me minimize this. This automation system is started only when I press the start button. You can see that there is a water flow towards the tank. Yeah, now what if the water is about 200 liters, the low layer sensor data will be on. And I know at any time, a point of time, I can turn off the motor by pressing the stop button. Yes. And whatever the water level may be, it will not be started even if the water goes below 200 liters because we have turned off the automation system itself. Now the water goes below 150, I mean around 150 liters. It will not turn on the motor. Why? Because we have stopped the system, automated system. If I press the start button again, it will be turning on the motor because at the same time it is draining out the water. We cannot see increasing in the water level. If I turn it off by pressing the right button, then the water level increasing I can see. See, it is going to turn off the motor. And we have programmed this. If there is a data from the sensor, they have to blink. Now you see when I open the tab by pressing the left button, the water drains out. And the motor will be turned on automatically when the water goes below around 150 liters. I mean 200 liters itself. Yes. So 1 liter comes out each time the instruction is executed. It takes nanoseconds. We know that for execution of each second. Yes. So as soon as the water drains below the 200 liters, the motor will be on. Yes. So at the same time, 1 liter is coming out and 1 liter is getting in. You cannot see increase in water level. I'll turn off by pressing the right button. So this is what the SCADA. Now I missed one particular interfacing that we can show here. select this sliding button. Then we have to go to event because we need to give input. Then whenever left button is pressed, it has to be true. So select three dots there, then choose variable, then object, then variable, double click on the tank tab, it comes here, then write equal, then true, then save, then exit. Similarly, when I press the right button, it has to be false. So select the three dots there, go to variable, object, and variable, tank tab, it comes, double click on that, it comes here, is equal to false. That is, when I press left button, the water has to come out. When I press right button, the water should not come out. So this is how I have linked this tab for animation purpose. Thank you. I hope it is clear how to develop SCADA screen for water level controller. I'm Naveen Kumar, logging out.